Hello and welcome back to Boxers Shorts. Today we are up to lesson 7 in our series on Earth's atmosphere and how it's been changing over time. In our last lesson we looked at these things called greenhouse gases. Today we are going to be looking at how humans, about how humans have changed the relative amounts of greenhouse gases that there are in the atmosphere. And then our next lesson, we will look at why that is such a problem. Before we get started today, there's a quick little starter here for you. So in your exercise book, please answer these questions. Okay, you guys should know the rules by now, that you pause the video when you want to answer questions. So if you haven't finished those questions, make sure it's paused now, because I'm about to go through the answers, and you should only be listening to my voice if you have done all these questions. Okay, describe how the amount of carbon dioxide in the atmosphere has changed over time. Now, by the way, I'm just going to squeeze this a bit smaller so that I can get a bit more onto the screen. There we go. Now, this is just a describe how questions. It's not asking us for any kind of explanation. So the amount of carbon dioxide over time has decreased quite drastically. It used to be over 90%. It's now around 0.04%. Describe how the amount of oxygen in the atmosphere has changed over time. That's increased. And again, it used to be pretty close to 0, and now it's around 20%. Nitrogen also increased. It used to be very, very tiny amounts, and now it's around 80% of the atmosphere. Water vapor has also decreased as the Earth cooled. What is a greenhouse gas? Oh, by the way, for all of these questions, okay, you do need to know why they changed, and you will definitely be asked questions like that in exams. Just at the moment, I'm only asking you the kind of to describe how they've changed as opposed to tell me why. But that doesn't mean to say that you don't need to know why. You do also need to know why. I'm just not focusing on it just now. What is a greenhouse gas? So this is a gas that traps or absorbs. Oh, sorry. Sorry, give me a sec. There we go. Right, absorbs long wavelength radiation. I think we're probably past the point where we would just write heat. So I think it's better to add that detail to your answer. So gas that traps or absorbs long wavelength radiation. And 3 examples of greenhouse gases. We've got carbon dioxide. We've got methane. And we've also got water vapor. Now, over the last 150 years or so, humans have been massively adding to these greenhouse gases and the amount of them that is in the atmosphere. So carbon dioxide over the last 150 years has gone up, and methane as well over the last 150 years, maybe a bit less, has also gone up. Now, it's important to note that we're not talking about anywhere close to the amounts that it was billions of years ago, right? So if we were to kind of, those are the notes we'll use later, so let's not do those. Let's, if we were to do a time thing, right? And then the amount of carbon dioxide. So if that's the amount of carbon dioxide and this is time, so this is say what year is it? 2021 right now. And this is, well, actually that's a terrible way to do it. So sorry, let's say this is today. And this is, 4 billion years ago. 4.6 billion years ago. So we're talking, this has gone down steadily over time like this, right? Until the point where it's here, this was like 90%, and this here is like 0.04%. So it's really tiny. And then if we were to zoom in and zoom in and zoom in and zoom in as far as we could get on here, this would look like that. Okay, so it's not even close to where it used to be in terms of all the way up here, but it is still an increase. And what we're going to look at today are 4 ways in which that increase has occurred. The first way is through the burning of fossil fuels. So if you take, say, a car, by the way, today is the day when you guys are going to get really familiar with the quality of my drawings. So inside the car, you have petrol. In order to make the car move, the petrol has to be burnt, and out of the exhaust pipe comes carbon dioxide. So that petrol used to be all locked up, right? It was kind of buried deep, deep, deep underground for many millions of years, untouched. Humans start digging it out and burning it, and that releases carbon dioxide from the petrol into the atmosphere. So that, of course, contributes to global warming. No, sorry, we're not up to global warming yet. So it just contributes to the amount of carbon dioxide that's in the atmosphere. Another way is if you take a forest with loads of trees. So as we know, these trees, the first tree was a lot better than the second tree. These trees are taking in carbon dioxide from the atmosphere the whole time. What humans do is they come along and they chop down these trees and they use the ground for other things. So they might put like animals on that ground instead, or they might just leave it and use the wood for, you know, furniture and paper and stuff. And what that means is that the carbon dioxide is no longer being pulled out of the atmosphere because those trees are gone. So it's not like a way of adding carbon dioxide to the atmosphere like this one is. So this one is, so the petrol is about, burning fossil fuels is about adding carbon dioxide. Deforestation, removal of forests, is about stopping carbon dioxide from being taken in. Now there's a further problem with these animals. Okay, so this here is a cow. These are cows, yeah, that's a pretty good picture of a cow, I'd say. I'm satisfied with that. Cows, and I don't think there's any polite way to put this, but cows fart a lot, and they fart a gas called methane, which is CH4. So all of these cows, they produce methane as part of their like normal digestive processes. Now, why is this a problem? Because methane is a greenhouse gas. It's also quite a lot worse than carbon dioxide as a greenhouse gas. It's a bit complicated how much worse it is because it does break down in the atmosphere over time. But like you can assume it's more than 25 times worse, right? So, you know, one molecule of CH4 is worth 25 molecules of carbon dioxide in terms of warming up the atmosphere, in terms of absorbing long wavelength radiation. So like one molecule of methane absorbs 25 times as much radiation as one molecule of carbon dioxide. So it's pretty bad. And there are now like billions of cows on the planet because humans love them for milk and for meat. So that is also a really big problem because they're constantly producing this CH4. Another problem associated with our food is the growing of rice. So rice plants, I've never seen one in reality, but rice plants sort of look a bit like that. And then on the top of one of them, they've got all the kind of little bits of rice, like a sheaf of rice. They might have on, you know, on another couple of bits like that. And that would be absolutely fine and dandy, and that wouldn't be a problem, except for the fact that they tend to grow underwater. So rice fields tend to have a lot of water. They're waterlogged. Paddy fields, they're sometimes called. And then the problem with that is that the bacteria that are in the soil over here, the bacteria in the soil everywhere, when they're underwater, they tend to produce carbon dioxide. No, sorry, not carbon dioxide, methane. They tend to produce methane. So those bacteria that are kind of submerged under that water, they're in the soil and under the water, they produce loads of methane. Now, you know, like you might think, well, what's the big deal? How much rice is there? Well, rice is a staple, which means it's the main source of energy in the diet of, you know, like half the world's population. So, you know, billions of people eat loads and loads of rice. So there are loads and loads of these rice fields, and that means loads and loads of this methane being produced. And again, like we said, methane can be at least 25 times as bad as carbon dioxide. So there we have 4 methods of altering the amount of greenhouse gas in the atmosphere. 2 are on methane, 2 are on carbon dioxide, burning fossil fuels, deforestation, cattle flatulating or just producing methane, and rice fields. Now I wrote those up for you in a short note over here so that you don't need to worry about exactly what to write down, because it's right here. So pause the video and write this down for me, please. Okay, you should have written that down now. It means we are time to do it's now time to do some questions. Where are we? Okay, so here we have a bunch of questions for you. Pause the video, have a go at these, and then we will go over them together. Okay, you should by now have done those questions, and you shouldn't be listening to my voice unless you have done these questions. And I just want to remind you that there is little point in doing these videos if you are not going to bother doing the questions. Okay, let's have a look. I think, yeah, here we are. So I opened some of them up. Great. All right, so explain why greenhouse gases can increase the temperature of the Earth. Okay, so I would say you can write they allow short wavelength. This is what we looked at last lesson. Wavelength radiation to pass from the sun to Earth, but they absorb, crucially, they absorb long wavelength radiation and prevent it leaving Earth. I think that's a nice way to put it. Oops, sorry. Okay, Earth should have a capital. There we go. All right, give the symbol formulae for carbon dioxide and methane. We just did those. Carbon dioxide and methane. Where are we? The farmer wishes to buy a forest which they can cut down and use land for cattle. So this is bad for 2 reasons. Okay, so deforestation prevents removal of CO2. Sorry, that's spelled really. There we go. Right. Deforestation prevents removal of CO2. And furthermore, cattle produce methane, CH4. Now, again, by the way, we've got 2 distinct things here. So this is like a really bad thing to do. And unfortunately, this is the case in a lot of places in the world at the moment, that they do deforestation, put cattle there instead because it's much more profitable. You make a lot more money that way. But it's like a double whammy. It's doubly bad. And yeah, so in exams, normally they'll say to you, 2 marks or whatever, give 2 reasons or the like, but you should be trying to get as much detail into your answers as possible. Again, like the point of these videos isn't to just get through them as quickly as you can, but it's to learn stuff. The student is asked to describe how the amount of carbon dioxide has changed, and they answer the amount has increased because humans burn fossil fuels. Like, why are they wrong? They're wrong because the question is about Earth's early atmosphere till now. So yeah, they might have increased in the last sort of 150 years after the Industrial Revolution, but they've increased by a tiny amount. Now that amount is significant and it makes a difference, but compared to Earth's early atmosphere, it's very, very little. So you need to start with saying that Earth's early atmosphere. So their problem is that they've not included Earth's early atmosphere in their answer. So you could just write Earth's early atmosphere, where you have carbon dioxide is more than 90%, is not included in this answer. And then you might want to add as well that the amount over billions of years has massively decreased. Now, the reason why I like emphasize this point so much is because there was an exam question a couple of years ago, which asked how has the amount of carbon dioxide in Earth's atmosphere changed over time, or whatever, changed over billions of years or whatever. And students just wrote about the Industrial Revolution and about releasing carbon dioxide on fossil fuels and stuff. And like, yes, all of that is true, but you've missed out a massive, massive part of it. And don't get confused between what's happened in the last 150 years and between what's happened over the last 4.5 billion years. Name 3 ways in which human activities increase the amount of carbon dioxide in the atmosphere. So we did 4. Deforestation was 1. Burning fossil fuels was another. We did cattle make methane or produce methane or release methane. And we did rice fields do the same. Now, by the way, on my screen, I'm seeing that there's it's being a bit weird and some of the writing isn't quite filling out. So I'm not sure if that's happening on yours as well, but it should turn up. It's just being a bit funny. I'm not sure why. 3 processes that can remove carbon dioxide from the atmosphere. So we did photosynthesis. This is 2 lessons ago now. Sorry, I'm just trying to adjust. Photosynthesis. We did locked up in fossil fuels. And we did locked up in sedimentary rock. And again, I'm not going to go into those in huge detail because we've done them now a few times. What is locked up carbon? It's carbon that cannot be easily released. Easily released. Like if I took a big lump of sedimentary rock and I put it in my garden, right, come back in 100 years and like the rock might be buried a bit, but like all the carbon would still be in that rock. It wouldn't go anywhere. I'd need to go to some serious effort in order to get that carbon out of the rock. I'd have to do a chemical reaction. I'd have to do thermal decomposition, which requires a lot of heat. It's a lot of energy. So, it's not an easy thing to do. The next one, student says that combusting natural gas, what a great question, does not change the amount, I say that, I'm the one who wrote it, does not change the amount of greenhouse gases in the atmosphere. We start with methane and we finish with carbon dioxide. In terms of locked up carbon, explain why the student is wrong. Okay, cool. So if we to do like a diagram of the ground, so at the start, you've got, so this is before you've burnt all that methane. So this is the start. You've got, this is the ground over here. And under the ground, you've got like big caves full of your natural gas, which is CH4. And then what you do is you burn that and you end up with, this is empty. And you've got CO2 up in the atmosphere, because what you do is you burn up that CH4 with oxygen and it turns into carbon dioxide and water. Should we quickly balance that? Yeah, we probably should. Let's put a 2 there. That looks like it's balanced with a 2 there as well. So you take that methane out, you burn it up, and you get carbon dioxide up into the atmosphere. So we've now got carbon dioxide in the atmosphere. Now the student is saying that you start with methane, which is a greenhouse gas, and you finish with carbon dioxide, which is also a greenhouse gas. So there's no change, but there is a change because at the beginning, all of that methane is trapped under the earth, right? It's not in the atmosphere. Yes, it's a greenhouse gas. If I were to just release that into the atmosphere, then yeah, that would be a problem. But for the minute, it's all like locked up in caves underground. So it's not greenhouse gas because it is a greenhouse gas, but it's not causing any problems because it's shoved underground like that. Whereas the carbon dioxide now that you're releasing goes off into the atmosphere and acts as a greenhouse gas and warms the earth up a little bit. In our next lesson, we will look at the greenhouse effect and what's called global warming. And then following that, we will look at climate change. Thank you for listening, and I will see you next time.